Hello, welcome to today's video. Today we're going to be going over repeated addition, as it's an intro for multiplication, something that we're going to discuss in the next video. But I'd like you to consider this first problem. It's 3 plus 3 plus 3 plus 3. So we could obviously go the brute force method and then add them all together one by one. So these two will be 6, and then if you add this, it'll be 9. If you add this 3 to 6, it becomes 9, and then you could add another 3, and then get 12. So we can conclude that 3 plus 3 plus 3 plus 3 is 12. Now, the other thing the other way that we can solve this is by changing this into another form. So basically changing this from addition to multiplication. This is basically just an intro to multiplication, but we will go more in depth next time. But basically this 3 plus 3 plus 3 plus 3 can become a 3 because we're adding 3's, and then we count how many times we add. We add 3. We add it 1, 2, 3, 4 times. So basically it's 3 times 4. Now you might be a slight bit confused, but this and this are exactly the same things. So this 3 times 4, we're basically just adding 3 to itself 4 times. So adding 3 to 0 4 times. So 3 plus 3 plus 3 plus 3, essentially. Now, over here on this table that I have made, we can actually see the answer to this multiplication problem. This multiplication problem right here. First, we find the number that we're multiplying, which is 3. And we find 3 right here. And then we go to the left 4 times. So this is 4 times, this many times. So if we go until here, then we find out that the answer is 12. And when we use this brute force method, we found out that it's 12. Now, here's the thing. The next problem is 4 plus 4 plus 4. Now, this, if we add them all together, it's 4 plus 4, which is 8, plus another 4 is 12. So then you're like, wait, 4 plus 4 plus 4 is also 12? But isn't 3 plus 3 plus 3 plus 3 12? Well, the thing is, if we go back to this board, we can see that if we take 4, because this time we're adding 4, and then we go all, if we add it to 0 3 times, then we also get 12. So we know that this is correct. But you might be wondering why. Well, many numbers can equal the same number. We know that. But basically this equation right here, the equation for this thing is 4, because that's how many times we're adding it, times 3. So now you might find some similarities between these two multiplication problems, and the similarity is that they're both the same thing. So these two equations or these two problems are the same thing, and the reason why they're the same is because similar to have an addition where you can swap out the numbers, like say 3 plus 2. 3 plus 2 is 5. Now you can just switch these around and then get 2 plus 3. Now this is also equal to 5 because it doesn't matter if you switch them around. It's still the same thing because it's addition. This property does not work with subtraction, only addition, and now, as you can see, multiplication. So we can switch these around and get 3 times 4, but these two things are actually the same thing. And the answer is 12 for both of them. So you can either go the brute force method, or you can just convert it into a multiplication problem and use a table. Normally, if you keep on using this brute force method, you'll eventually memorize the answers for these small numbers, such as uh, 3 plus 3 plus 3 plus 3. You're gonna memorize it eventually, so you don't have to go through the trouble of memorizing this whole table just yet. Once you start using this brute force method, you'll eventually memorize it by yourself. So now let's look at this equation up here. 6 plus 6 plus 6 plus 6. Now, if we use the brute force method, we can see that 6 plus 6 is 12. If we add another 6, it's 18. If we add one more 6, it's 12. It's 24. Now, if you want to do this like in your head without any paper, you can use your hands and use say in this problem you can just use your like thumb for 6, and then you keep on raising your finger as you add 6. So then you can make sure that you added 6 4 times. So then if we add 6 4 times, you get 24. And now again, if you're doing it in your head, you can use your fingers. So say this first finger is 6, second finger is 12, third finger is 18, and fourth finger is 24. So you can make sure that you added 6 4 times using your finger. You can't use paper. And now let's try converting this into a multiplication problem. So we know that we're adding 6, so it's 6. And we're adding the 6 4 times. So it's 6 times 4. And 6 times 4 is 24. And we can see that by looking at this table. If we look at 6 here on this column, we can go 4 to the right. So until this, it's getting a bit messy, but bear with me. If we go 4 to the right using 6, so if we add 6 to itself 4 times, we see that we get 24. Now that we have enough experience, I guess, converting the addition into multiplication, we might as well try to do it the other way around. So 7 times 4. If we look over here on the table, if we look for 7, so it's right here, And then if we multiply it by, you know what, let's do 5, because let me just do it again. So if we multiply 7 by 5, so first we found 7 on this column, then we look at the rows, the first row, and then we look for 5. Then if we go down, you find that 7 times 5 is 35. Now, if say you want, if say you haven't memorized the table, or if you can't use it, we can always just convert this into repeated addition. So bring we can make this, so we know that now this can go either way. We can make it 7, and since it's times 5, we add 7 5 times. 7 plus 7 plus 7 plus 7 plus 7, or we can add 5 7 times. Now, if we use the brute force method on either one of these, we'll find that the answer is still 35. So let's take 7 plus 7 plus 7 plus 7 plus 7. If we add 7 plus 7, that's 14. Another 7 is 21. Another 7 is 28. And one more 7 is 35. Now, this is 35. And if we look over here, we get the same result. 5 plus 5 is 10, plus another 5 is 15, plus another 5 is 20, plus another 5 is 25, plus another 5 is 30, and plus the last 5 is 35. So we get 35. Now, one last problem, I guess. And let's use 8, no, let's use 12 times 1. So if we look at this, this is actually a really easy problem. We don't even need the table. So we can use either one, but it would be most efficient to use this for the number that's getting added. So we're adding 12 one time. So only 1/12. And 12 is equal to 12. Now that might sound a bit obvious, but it's the truth, right? So you can just get 1/12 and that's equal to 12. Or we can add 1/12 times, and then, okay, yeah, that's not 12 times, but you get the gist. It's going to be 12. Just like 12 times 1. If we add 12 one time, it's going to be 12. Now, for real, this is the last one. So, this is actually the last one. So, let's use 14 times 0. Now, we're adding 14 0 times. So, we're not adding anything at all. Because this over here, 14 times 1, would be adding 14 one time. But this time, we're even taking away this 114. So 14 times 0 is nothing. And nothing is 0. So another way to think of this is basically 0 plus 0 plus 0 14 times. And it doesn't matter how many times we add 0 to itself, because it's still going to be 0. Right? It doesn't matter how many times we add 0. Even if we add 0 like a billion times, it's still going to be 0. So, either way, and this works for any number. Any number, even let's take 1 billion times 0 is still going to be 0, because it's 1 billion 0 times, so we're adding 1 billion 0 times, so we're not adding anything. Or we can just think of it like as 0 plus 0 plus 0 plus 0 plus 0 plus 0 a billion times. Either way, it's going to end up being 0. So any number times 0 is going to be 0.